So, what if you could literally write the source code for the universe? I mean, really think about that. Today, we're going to dive into what might be one of the most ambitious projects out there. It's an attempt to pull together physics, information, even consciousness itself, and not just as a theory on a whiteboard, but with actual running code. You know, we all learn in school that the universe is basically made of space, matter, and energy, right? But what if there's this hidden ingredient that we've been missing? What if reality itself, at its most fundamental level, is actually built on information? If you can wrap your head around that one idea, you're on your way to understanding this whole new, kind of radical blueprint for the cosmos. Okay, so why is putting information first such a big deal? Why is it so radical? Well, it's because it's trying to solve the biggest problem in modern physics. I'm talking about a problem we've been stuck with for about a century now. We have two amazing theories for how the universe works, and they just don't play nice together. They completely contradict each other. All right, so on one hand, you've got Einstein's general relativity. It's this beautiful, elegant rule book for all the big stuff, planets, galaxies, the very fabric of space-time. And then on the other hand, you have quantum mechanics. It's weird, but it's super accurate. It's the rule book for the teeny tiny world of atoms and particles. Now, here's the problem. What happens when you try to describe something that's both massive and tiny, like a black hole? Well, the two theories just clash. The math falls apart. It breaks. And because of that clash, for decades now, the absolute holy grail of physics has been this quest to find a single unified theory. One elegant set of rules that could explain everything, from the smallest little quark all the way up to the biggest galaxy clusters. That's the ultimate price, the whole shebang. Okay, so this is where our story takes a really interesting turn. A new contender has stepped into the ring, right into this search for a unified theory. It's a framework with it's got a super long name, so we're just going to call it by its acronym, SUTQRD. SUTQRD. It stands for Schmidt's Unified Quantum Relativistic Dynamics. But honestly, its goal is so much bigger than just uniting physics. It's trying to weave information and, even consciousness right into the very fabric of reality. So think of it this way. This isn't about patching up the old map of the universe. It's about drawing a completely new one from scratch. So, how does this new map even work? Well, it's all built on three main ideas or axioms. The first one is the movement axiom. Pretty simple. Things move in a straight line unless energy makes them curve. That's classic physics. We get that. The third one, the dynamics axiom, is also pretty intuitive. You need energy to make any kind of change happen. But it's that second axiom in the middle that's the real game changer, the information axiom. It says that information isn't just some abstract idea. No, it's a real physical thing that gets created by stimuli. And this is the key part. This information is what comes before consciousness and making decisions. These three rules together, they're the foundation for everything else in this theory. This new way of looking at things, it totally reframes some of our most basic ideas. Take time, for instance. In this model, time isn't just a clock ticking on the wall. It's, get this, the carrier of energy conversion. Just let that sink in for a second. Every single thing that happens, every physical process, every thought you have, every decision you make, it's all a conversion of energy from one form to another. And time is just the medium that lets all of that change happen. And here's where it gets really wild. This is where the theory stops being just theory and becomes something you can touch, something tangible. See, SUTQRD isn't just a bunch of equations scribbled on a whiteboard. No way. It's an active, honest-to-goodness software project. They're building a simulation based on these exact principles. So they're not just thinking about it, they're literally trying to code the cosmos. And listen, you've got to understand, this is a serious piece of engineering. Just take a look at the technology they're using. For the quantum side of things, they're using QSKID. That's IBM's quantum computing framework. For the AI modeling, they're using TensorFlow, which you probably know is Google's powerhouse AI engine. We're talking about a professional, modern, complex application here, all built to test one of the most massive ideas in all of science. So what are they actually building with all this cool tech? Well, some really mind-bending stuff, to be honest. They've got something called a quantum tesseract V, which, get this, uses quantum principles to help us visualize a four-dimensional hypercube. They've got a simulator to model the collapse of the quantum wave function, that moment of measurement. And maybe the most ambitious part of all is this unified reality system. It's trying to show how the classical world we live in, the weird quantum world, and this new information world all interact with each other, all at the same time. I mean, trying to build a simulation of reality itself, as you can probably guess, that's just insanely complex. It's exactly why they're building the whole thing to be modular and hybrid. It's the only way you can get all the different parts, the quantum simulator, the AI, the front end, to all talk to each other and work together in a way that's stable and can actually grow. Okay, so we've got this unified theory, and we've got this seriously complex piece of software trying to model it, but so what? What does this actually mean for you and me? Why should we care? Well, this is where it gets really exciting, because the potential applications are, honestly, they're staggering. Yeah, this isn't just some abstract physics experiment for a handful of scientists. You should think of it more like a launchpad for a whole new generation of technology. The work being done here could feed directly into some truly revolutionary fields. We're talking about quantum AI, brand new types of cryptography, and it might even help us finally dig into the quantum weirdness of biology and consciousness. Let's just grab one of those as an example. Quantum natural language processing, or QNLP. Right now, our AI is pretty good at processing words, but it doesn't really understand them. The big idea with QNLP is to use the principles of quantum mechanics to build AI that can grasp nuance, context, and the real meaning behind the words, kind of like how we humans do. And then there's security. This is huge. The really deep, complex math inside this theory, things called spin networks, could be the very foundation for a whole new kind of cryptography. In fact, the project is already using what's called quantum-resistant algorithms just to keep its own data safe. The endgame? To create encryption so strong that even the quantum computers of the future won't be able to crack it. So in the end, everything we've talked about, the deep physics, the complex code, all the crazy applications, it all points back to one single, incredibly audacious goal. And that is to build a unified model of reality. A model where physics and information and our own minds aren't seen as separate things, but as one deeply interconnected system. And that leaves us with one last kind of mind-bending question to chew on. If you can figure out the unified rules of the entire cosmos, and then you build a simulation that actually runs on those rules, are you just observing reality anymore? Or are you on the verge of actually coding it? That's a question that pushes right to the edge of what we think of as science and philosophy. Thanks for diving into this with me today.